Okay, sorry about that. I guess the lost the internet connection. We were talking about this, call this 1.4b, and we're talking about Pythagorean identities for trig. And we were talking about sine squared theta plus cosine squared theta equal to 1. And we said with some algebra trickery, we can rewrite these. But let's look at the sine squared theta. Sine squared theta really means sine of theta squared, which means sine theta times sine theta. We just use this. This is a convenient way of writing it, but this is actually what it means. It means the sine of theta twice. Okay, so when you see something like that, the identities we've been using so far didn't have squares in them, and the square is important. It's not, if you put sine plus cosine, it's not going to equal 1. So we have to be kind of careful. Another one is tangent squared theta plus 1 equals secant squared theta. And again, you could rewrite this as moving this tangent to the other side and say 1 equals secant squared theta minus tangent squared theta. You could write it like that. And another one would be cotangent squared theta plus 1 equals your cosecant squared theta. These are a little bit harder to remember because, you know, we can see sine and cosine kind of go together, but tangent and secant, you know, kind of don't seem like they have much in common. But this is an identity. Identities can be proven. We're not going to go through and prove all these, but they could be proven. Two other ones that we're going to look at, they call these the quotient identities. Put it this way, or the tangent identity. These two we use a lot, especially the first one, the cotangent, the tangent theta. Notice it doesn't have a square, is equal to the sine theta over cosine theta, which means it's sine theta divided by cosine theta. And likewise, its buddy, the cotangent theta, is the reciprocal of this cosine theta divided by sine theta. Let me give you a quick example of this one. Let's say we know the sine is, theta is 1/2, and the cotangent theta, not cotangent, but cosine theta, is 1/3. And we want to find the tangent. Tangent theta would simply be 1/2 divided by 1/3. I prefer to do it this way. The book kind of puts 1/2 over 1/3 and all that kind of stuff. So it's easier to write it this way, and we could say that's 1/2 times the reciprocal, 3 over 1. So we know the tangent of theta is going to be 3/2. So it's kind of useful. If we know the sine and cosine, we can figure out the tangent really fast. Kind of saves us a little bit of work. Let's see if they have any examples in the book on that. I don't see any. All right, so let's try the last two examples. Example 6, page 34. Interesting little problem. They want us to find the sine of theta. They want us to find the cosine, the tangent of theta, excuse me. And all the information they gave us was that the cosine of theta is negative radical 3 over 4. And they also told us that the sine of theta is going to be positive. It's greater than 0. Positive. So we know, again, all students take calculus, that the sine is positive in the first and the second quadrant, but It can't be in the first because the cosine would also have to be positive, and we see it's negative. So we know this angle, we're looking for an angle in the second quadrant. We could do this by graphing it. We have by this method right here, and we know the cosine, the definition of the cosine is x over r. We could do it like we did that one problem, but they want us to do this by identities. So we need an identity. Well, there's two identities we could maybe use. Tangent theta equals sine over cosine. But I don't think that's going to help us a whole lot. So let's go to the other one. Sine squared theta plus cosine squared theta equals 1. And if we want to find sine squared theta, we could say sine squared theta equals 1 minus cosine squared theta. And we could just substitute these in. Let's do it right here. Sine squared theta would equal 1 minus, well, cosine is negative radical 3 over 4, but we want to square that. Okay, so we're squaring that negative. So that would be what? 1 minus radical 3 times radical 3, and it would come out a positive 3 and over 16. So now we got 16 sixteenths minus 3 sixteenths would give us 13 sixteenths. And now we know what the sine squared theta is equal to, but we want to know what theta sine is. So we're going to take the square root of both sides, and sine theta, we want to take the top and the bottom. Sine theta is the square root of 13 over 4. And now we know what sine of theta is. So kind of a nifty little way of finding the sine of theta. Now I still want to find a tangent. So tangent theta, what do we know about it? Well, we know it's the sine of theta divided by the cosine of theta. Okay, so tangent theta, and notice this one's not squared, is equal to the sine, which is radical 13 over 4, divided by the cosine, which was a negative radical 3 over 4. Okay, so when we are dividing, we use reciprocals, 13 over 4. Let's change this to times, bring our negative to the top. We also knew that this was plus or minus. We knew this was going to be plus because it was in the second quadrant. Okay, so this would be 4 over square root of 3. We're going to cancel those out. So I end up with negative radical 13 over 3, radical 3. But that's what tangent theta is. However, we want to rationalize radical 3. So this is radical 39 negative over 3. This is the square root of 9. Okay, so we've got our two answers, tangent, sine. A little bit of work. You got to find the sine first, and then from the sine, you got to do a little square rooting and things like that, quite a bit of algebra, and you get your answer. Okay, the last example, another one of these little tricky ones. Okay, on this one, they said the sine theta, we're looking for sine theta, cosine theta. And we know the tangent of theta is 4 over 3. And again, we might be able to do it by some calculation using the quadrant thing. But again, using the our functions and things like that, but we want to use the identities. So they told us this is in the third quadrant. So in the third quadrant, we know the tangent will be positive. We know both of these are going to come out negative. So we know what signs we're going to put in front of them. That helps a lot. So we know the tangent is sine over the cosine. Might seem a good way to start, but then again, what do you do after that? So I think a better approach would be tangent squared theta plus 1 equals secant squared theta. How's that going to help us? Well, we know that the cosine and the secant are reciprocal buddies, so that might help a lot. Let's rewrite this a little bit. Well, we could actually just use it the way it is. Let's just keep it as the way it is. In place of a tangent, we're going to put 4/3 squared plus 1 equals secant squared theta. We're going to square that. That'll be 16/9 plus 9/9, right? It's in place of y. 1 secant squared theta. And then we're going to take the square, we're going to add it up, 25/9 equals secant squared theta. But now I want to know what secant is, so I'm going to take the square root of both parts, and we know plus or minus, we're going to use the minus value. We're going to use that minus value. So secant theta, which is right, secant theta equals a negative 5/3, 5/3. So how's that going to help us? Well, with the secant is negative 5/3, therefore the cosine is its reciprocal buddy, and it's got to be 3/5, and it's still got to be negative 3/5. So now we know the cosine. So how do we find the sine? Well, we do it like last time. Sine squared theta plus cosine squared theta equals 1. So it's kind of like a detective story. First, we're going to find the secant. Secant didn't lead us directly there, but it kind of gave us a